karanjetlilive.
Hi guys, welcome to my channel, and today in this video we are going to discuss unbounded concurrent lock-free stack. Okay, so guys, in this example we'll be implementing stack as a linked list. We'll be implementing stack as a linked list. Normally if you see stack, if you have studied data structure, normally the stacks are implemented in form of an array. They are implemented in form of an array where all the elements are deleted from the top and they are inserted also on the top. Okay, so for example, if I want to insert x, so the top moves up. Okay, if I want to delete x, the top moves down. Okay, but in this example we are going to implement our stack as a linked list. Okay, as a linked list. Now what is a linked list? Linked list is a collection of nodes, which is each node is divided into two parts. One part is called as value, another part is called as link. Okay, and link points to the next node. Again, that node is divided into two values, parts called as value and link, and so on. Okay, so when we implement stack in form of a linked list, okay, for example, here is value a, b, c. Okay, and the first node is called as top. The first node is called as top. So if I want to insert any element, for example, in case I want to insert element d, so it will be inserted at the top. So the top will point to d and link of d will point to the old top. Okay, and this d will be inserted. And similarly, if we want to delete anything, we will delete it from the top and we make the new top as the next of the old top. Okay, so that way our linked list, it can act like a stack. So guys, in this video we will be studying concurrent stacks, okay, which are unbounded. Unbounded means the stack is unlimited. You can push as many element as you want. Okay, and it will be implemented in form of a linked list. Okay, and we won't be using any locks in it. Okay, so guys, the first thing first, so this is a structure of a node. Of the linked list. Okay, so what it has a node, as I told you. It has a value. Then in the value it stores the data, whatever you want to store, and then it has next. So next is nothing but a link to the next node, but it is a link or it is a pointer to the next node. Okay, so this is the structure of my node. Okay, so initially we have only one node. Which stores some value, and next of link is null. Because there is not any other nodes in the linked list. Okay, so stack has only one element, and it does not have any other element, so the link is null. So this is the structure of my node. Value represents data, next represents the address of the next node, and node represents one node in the linked list. Okay, so now coming to the point. Okay, so this next part which comes is called as push operation. Now guys, what is a push operation? In push operation, what do? We insert the element in the stack. And where the element is inserted in the stack, it is inserted in something called as top. Okay, so top of the linked list, we will insert the element. Now let us see the algorithm. Of unbounded lock-free concurrent stack. So guys, here we are using atomic references. For the top. Now guys, what happens when we talk about concurrent stack? Many threads, they try to push the element and they try to pop the element at the same time. So top of the stack is highly contended. Okay, it is shared between different threads which are trying to push, and it is also shared between different threads who are trying to pop the element from the stack. So what happens is the top is a highly contented among many different threads. So one way of making the top consistent is using locks. Using locks I can make my top consistent, but I have to manage the locks. I have to lock the top. If I want to do push, then I have to unlock the top after I have done push, and same applies for pop. Okay, so to avoid all this, what I do is I use atomic reference variables. So what atomic reference variable does, it controls the access to the top. The Java virtual machine, it will control the access to the top so that it remains consistent, without user worrying about the locks. So what do we call it? We call it as atomic reference. Okay, Java virtual machine will take care of all the inconsistencies, it will take care of all the race conditions and so on. Okay, so then the next thing which we use is min delay and max delay. Okay, so what is min delay? In min delay, what we do is we set the minimum time where a push or pop operation has to wait before trying again to do push or pop, and same is the maximum delay. Okay, so minimum and maximum delay is the time period. Okay, time period where the different threads they try to do the push or pop. It is the delay between the push and pop before they can try to do it. For example, some thread is trying to push, it is unable to push. So how much time minimum it will wait and how much time maximum it will wait before it tries to do the push operation again. And same applies for pop. It is a time interval, okay, which is decided by the minimum delay and the maximum delay. Okay, so then what happens is then we have back off. As I told you, back off works with the minimum and maximum delay. Means if any thread tries to put push an element into the stack, okay, if it is successful, fine, otherwise it backs off for this period of time which is decided by the minimum and maximum delay. Similarly, if a thread wants to pop an element from the stack, okay, if it is successful, very good. If it is not successful, then again it backs off for this period of time. So this is the job of back off. Okay, now guys, let us do the push operation. Okay, so guys, when we talk about lock free stack, so the push operation, it uses another Boolean operation called as try push. Try push. So what is with try push? Try push, if it is successful in pushing the element, then it will return true. If it is not successful in pushing the element to the stack, then it will return false. Okay, if it is not successful, then it will wait for some time and try again. Until it is successful. So what is try push? It is a Boolean operation which will try to push an element into the stack, and if it is successful, it will return true, and if it is not successful, it will return false, and it will back off. It will wait for some time and again it will try. So guys, I hope till now things are clear. So what is atomic references? What is minimum delay? What is maximum delay? What is back off? And what is the use of try push? Now let us try to push an element to the stack. Okay, now here, as I told you in the beginning, our stack is implemented in form of a linked list. Suppose this is the top and element stored at top is A. So it points to the next element B. It points to the next element C. And after C there is nothing. And address of this linked list is, for example, node is 100. The address of this node is 200, 300. Okay. So A points to B. So what is the link of A? What is the pointer to B? What is the address of B? 200. So here goes 200. B points to C. What is the address of C? 300. Okay. And guys, here is the top. Here is the top. So top points to the first node always, up to the top of the stack. So what is the address of this? 100. So what is the address of this? 100. Okay. So suppose this is our stack. This is our stack. Now let us try to push an element to it. Let us try to push an element to it. So we call the push operation. New node is equal to new node value. So whatever, take a new node from the list of free pool. Okay. Take a node from the list of free pool. So then what you do? Insert the value in the new node. Suppose guys the value is D. So we put it here. We put it here. Okay. So while true, try push. Now suppose the address of this node. Okay. So all you know, in the linked list every node has a address. The address of this node is 400. Okay. So then what we do is while true. So we keep on running the loop. If try push node. So we call the method if try push. Okay, if and try push, and we push the node in this. We send the node here. We send the node here. So what comes here is the node. Which node? This node. Okay, this node comes here. So node old top is equal to top dot get. So create a variable called as old top. Okay, so what value we took? Put in that top dot get. So what is in top? Top is 100. So when we get the value of 100, a top, that is 100. Where do we store it? We store it in the old top. 100. Old top is equal to top dot get. Okay. So node dot next. Node dot next. Which node came here? That is this one. Node dot next is equal to old top. So node dot next, what goes in the next of this? Old top. So what is an old top? 100. So comes here. Okay. Now this node, it points to this node. This node, it points to this node. Now return top. Okay. Compare and set old top with node. Okay. Now what is compare and set operation? What is compare and set operation? Compare and set operation will compare these two values, old top, and it will compare the address of the node which came here. So what is the address of the node? 400. What is the old top? 100. Now what does compare and set does? Compare and set does, if it will compare these two values, okay, if they both are same, then it will not do anything. Then it will not do anything. Okay, if they are different, then it will change the value. Okay, replace the value of these two with the top, value of top. Now what is value of top? 100. What is value of old top? 100. So they both are same, so it does not do anything. So what is the value of node? 400. Okay, so the value of the node is 400. So it sets the top to 400. It sets the top to 400 and it returns true. So if compare and set is successful, it will return true. So what is the value of new top? The value of new top is 400. So it does not point here anymore, rather top points here. So after this, so what is this? Top becomes this, next of top is this, and next of top is this, and element inserted. And element inserted. So after insert, this is how my linked list looks like, or this is how my stack looks like. 400 points to D, and D points to A, and A points to B, and B points to C. Okay, so D, okay, what is the address of D? 400. What is the address of A? 100. What is the address of B? 200. And what is the address of C? 300. So this is my new stack looks like after I am able to insert the value. Okay, so then this operation is successful, so it returns true. So what comes here is true. If true, then return, come out of the loop, do not do anything. If it is not successful, so if the old top and the new top, they both are same, means we are not able to insert any element, then this false, then we call back off, then we stop trying for some time, and after this minimum and maximum period of time, we try again. Okay, so guys, I hope you understand it. So let us do one more example quickly. So after inserting the element, this is my top. Okay, this is my stack. So let me try one more element. Okay, the value suppose of that is E. Okay, value of that is E, and suppose the address of E is 600. Okay, quickly let us do it. Okay, try push value. Okay, so new node, insert the value. So this is the new node. So I push the value E. So this is my node. I call try push, and this node comes here. So what is the node which comes here? The value is E and the address is 600. This node comes here. Okay, so node old top is equal to top dot get. So old top dot get. So what is in top? 400. So what we store in old top is 400. Node dot next is equal to old top. So this is my node. So next of this is old top. So what is in old top? 400. So in E, the next of E points to 400, that is here. Okay, return top. Compare the top with old top and the node address. Top compared with old top is same. So we cannot do anything. It remains same. So top dot compare with node value, that is 400 compared with 600. So we replace 400 with 600. So what it does now, top points to the new node, new top, and this is my linked list. And what it returns? It returns true, and here we get the true. If true, then we come out of it, and our push is complete using try push. So guys, I hope this is clear. So now guys, let us try with pop. Okay, now suppose this is our linked list. Okay, so this is the top points to 100, A, B, C. A is 100, B is 200, C is 300, next of C is null, next of A is 200, next of B is 300. Now, so pop operation, suppose this is our stack. The first element on the top is A, then A is pointing to B, B is pointing to C, and these are their addresses, Now suppose I want to pop. The element. Okay, so let us do while true, start the loop. Node, return node is equal to try pop. So I create another variable called as return node. So the result of try pop, whatever is the result, will be stored in the return node. Okay, here comes the try pop. If node old top is equal to top node old top is equal to top dot get. So here is my old top dot get. So whatever data is in top goes to old top 100. If old top is equal to null, means there is nothing in the stack. Okay, but here in this case it is not null. Suppose there is nothing in the stack, top has null means my stack is empty, then it will throw an empty exception. But in this case it is not null, isn't it? What is an old top? 100. So we skip this part and we come here. Node new top is equal to old top dot next. Now I have another variable, new top. New top is equal to old top dot next. So what is old top? 100. 100 dot next is what? 200. So what goes in new top? 200. Okay. If top, compare and set old top and new top. Compare and set old top with old top and new top. Okay, so now this top is compared with old top. 100 compared with 100, nothing happens, isn't it? Now top is compared with new top. 100 compared with 200, swap happens because they are not same. So this comes 200, this comes 200, and now the top points to node 200. The top points to node 200 and this node is automatically removed. And what is the result of this operation? The result of this operation is true because this compare and swap is set is successful. So it returns to return old top. Now what happens is return the old top. So what is old top? Old top is returned back. So what comes in return node? The value of old top. So what is old value of old top? 100. What is value of old top? 100. So then return node dot value. So what is the return node? 100. So what is the value in the return node? A. So what value it will return? It will return A. So the top is deleted. So what was at the top? A. So then if it is successful, then fine. If this is true, then fine. Okay. Otherwise, back off. So it returned some value. So it is not null. So this will be executed. Okay. So if it was null, so then back off would have been executed. Okay. So guys, let us do pop again. Let us do one more example of pop. Okay. So after deleting the first node, so this is my stack now. Okay. So let us call again. What do we call again? We call pop. So this pop should remove the element B from the stack. Okay. Now return node is equal to try pop. So I come here. Okay. Node old top is equal to top dot get. Old top is equal to top dot get. So whatever value is in top, put it in the old top. So what is here? 200. Now if old top is equal to null, is old top equal to null? No. So we skip this part, we come here. Node new top is equal to old top dot next. Now I have another variable called as new top is equal to old top. What is old top? 200. What is next of 200? Is 300. So what comes in new top? 300. Okay. Now we do the compare and set operation. Top, compare and set with old top and new top. So this top is compared with old top 200, nothing happens. When it is compared with new top 300. So compare and set. So what we do? We replace this 200 with 300. 300. We replaced this 200 with 300, and what is the result of the operation? The result of this operation is true because compare and set was successful. Okay, so now the top points, instead of pointing here, it points to here, 300. Okay, so then return old top. Okay, so the old top, what is the value of old top is 200. It is returned here. So what is stored in return node? What is stored in return node? 200. Okay, so then return dot node dot value. So this is the return node. So what is the value here? B. So what it returns? It returns B. Okay, so if it was not successful, it would have sent a null and we would have come here. We would have called the back off. So guys, this was our unbounded concurrent stack. So guys, I hope it is clear to you. And guys, if you like my videos, please subscribe to my channel. I'll be uploading more lectures related to information technology and much more. So guys, all of you, thanks for watching and stay tuned.